Electroplating is a process that uses electric current to reduce dissolved metal cations so that they form a coherent metal coating on an electrode. The term is also used for electrical oxidation of anions onto a solid substrate, as in the formation silver-chloride on silver wire to make silver-chloride electrodes. Electroplating is primarily used to change the surface properties of an object, but may also be used to build up thickness on undersized parts or to form objects by electroforming. The process used in electroplating is called electro deposition. It is analogous to a galvanic cell acting in reverse. The part to be plated is the cathode of the circuit. In one technique, the anode is made of the metal to be plated on the part. Both components are immersed in a solution called an electrolyte containing one or more dissolved metal salts as well as other ions that permit the flow of electricity. A power supply supplies a direct current to the anode, oxidizing the metal atoms that it comprises and allowing them to dissolve in the solution. At the cathode, the dissolved metal ions in the electrolyte solution are reduced at the interface between the solution and the cathode, such that they plate out onto the cathode. The rate at which the anode is dissolved is equal to the rate at which the cathode is plated, vis-a-vis the current through the circuit. In this manner, the ions in the electrolyte bath are continuously replenished by the anode. Other electroplating processes may use a non-consumable anode such as lead or carbon. In these techniques, ions of the metal to be plated must be periodically replenished in the bath as they are drawn out of the solution. The most common form of electroplating is used for creating coins such as pennies, which are small zinc plates covered in a layer of copper. Effects: electroplating changes the chemical, physical, and mechanical properties of the workpiece. An example of a chemical change is when nickel plating improves corrosion resistance. An example of a physical change is a change in the outward appearance. An example of a mechanical change is a change in tensile strength of surface hardness, which is a required attribute in tooling industry. Electroplating of acid gold on underlying copper nickel-plated circuits reduces contact resistance as well as surface hardness. Copper-plated areas of mild steel act as a mask if case hardening of such areas are not desired. Tin-plated steel is chromium-plated to prevent dulling of the surface due to oxidation of tin. History: modern electrochemistry was invented by Italian chemist Luigi Valentino Brunelleschi in 1805. Brunelleschi used his colleague Alessandro Volta's invention of 5 years earlier, the voltaic pile, to facilitate the first electro deposition. Brunelleschi's inventions were suppressed by the French Academy of Sciences and did not become used in general industry for the following 30 years. By 1839, scientists in Britain and Russia had independently devised metal deposition processes similar to Brunelleschi's for the copper electroplating of printing press plates. Boris Jacobi in Russia not only rediscovered galvanoplastics, but developed electrotyping and galvanoplastic sculpture. Galvanoplastics quickly came into fashion in Russia, with such people as inventor Peter Bagration, scientist Heinrich Lenz and science fiction author Vladimir Odojevsky all contributing to further development of the technology. Among the most notorious cases of electroplating usage in mid-19th century Russia were gigantic galvanoplastic sculptures of St. Isaac's Cathedral in St. Petersburg and gold electroplated dome of the Cathedral of Christ the Saviour in Moscow, the tallest Orthodox church in the world. Soon after, John Wright of Birmingham, England discovered that potassium cyanide was a suitable electrolyte for gold and silver electroplating. Wright's associates, George Elkington and Henry Elkington, were awarded the first patents for electroplating in 1840. These two then founded the electroplating industry in Birmingham, from where it spread around the world. The Woolrich electrical generator of 1844, now in think tank Birmingham Science Museum, is the earliest electrical generator used in an industrial process. It was used by Elkington's. The Norddeutsche Affinery in Hamburg was the first modern electroplating plant, starting its production in 1876. As the science of electrochemistry grew, its relationship to the electroplating process became understood, and other types of non-decorative metal electroplating processes were developed. Commercial electroplating of nickel, brass, tin, and zinc were developed by the 1850s. Electroplating baths and equipment based on the patents of the Elkingtons were scaled up to accommodate the plating of numerous large-scale objects, and for specific manufacturing and engineering applications. The plating industry received a big boost with the advent of the development of electric generators in the late 19th century. With the higher currents available, metal machine components, hardware, and automotive parts requiring corrosion protection and enhanced wear properties, along with better appearance, could be processed in bulk. The two world wars and the growing aviation industry gave impetus to further developments and refinements, including such processes as hard chromium plating, bronze alloy plating, sulfamate nickel plating, along with numerous other plating processes. Plating equipment evolved from manually operated tar-lined wooden tanks to automated equipment, capable of processing thousands of kilograms per hour of parts. One of the American physicist Richard Feynman's first projects was to develop technology for electroplating metal onto plastic. Feynman developed the original idea of his friend into a successful invention, allowing his employer to keep commercial promises he had made but could not have fulfilled otherwise. Uses. Electroplating is widely used in various industries for coating metal objects with a thin layer of a different metal. The layer of metal deposited has some desired property, which the metal of the object lacks. For example, chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, wheel rims, and many others, for the fact that chromium is very corrosion resistant and thus prolongs the life of the parts. Electroplating has wide usage in industries. It is also used in making inexpensive jewelry. Electroplating increases life of metal and prevents corrosion. Hull cell. The Hull cell is a type of test cell used to qualitatively check the condition of an electroplating bar. It allows for optimization for current density range, optimization of additive concentration, recognition of impurity effects, and indication of macro throwing power capability. The Hull cell replicates the plating bath on a lab scale. It is filled with a sample of the plating solution, an appropriate anode which is connected to a rectifier. The work is replaced with a Hull cell test panel that will be platted to show the health of the bar. The Hull cell is a trapezoidal container that holds 267 milliliters of solution. This shape allows one to place the test panel on an angle to the anode. As a result, the deposit is platted at different current densities which can be measured with a Hull cell ruler. The solution volume allows for a quantitative optimization of additive concentration. 1 gram addition to 267 milliliters is equivalent to 0.5 ounces gal in the plating tank. Herring-Blum cell. The Herring-Blum cell is used to determine the macro throwing power of a plating bar. The cell consists of two parallel cathodes with a fixed anode in the middle. The cathodes are at distances from the anode in the ratio of 1 to 5. The macro throwing power is calculating from the thickness of plating at the two cathodes when a DC current is passed for a specific period of time. The cell is fabricated out of perspex glass.